Hey, so, welcome. I hope you had a good lunch break. And I got this wonderful slot right after lunch where everyone had wonderful food and are sleepy. Okay, so I'm Anders Abel. I work for Duendo Software. We do login buttons, to put it simply, or identity and access management solution involving Duendo Identity Server, but also a lot of other components. And what we see in our support forums, consulting work, etc., is that there are a few basic concepts that obviously are not that easy to grasp, because we often see that problems are based on these basic factors. So this talk is mostly about trying to take three topics that kind of make up at least half of our support issues, or turns out to be the root cause of half of our support issues, and turn them into talk so that you won't have to make these mistakes, because you will know these topics and how the setup works afterwards. So first of all, I started drafting this talk and said the title, let's do ASP.NET Core Auth. Because that's simple, because Auth could mean both authentication and authorization. So if you say Auth, nobody knows which one of them you're meaning. But what's the difference? So you're all here, so either you're local or you were let in to Norway. To be let into Norway, this poor guy here, he is not being let in. And there are two versions of this story why he is not let in. One is that the photo and characteristics doesn't match, so nice try, but this is not your passport. The other one is, yeah, it's a valid passport from Faroestan. It's honest, but no, I mean, the Norwegian restrictions and embargoes against Faroestan are heavy, so those citizens are not let in. One of these is that he's failing authentication, the other one is authorization. So let's make a poll. So how many think the first one is authentication? Does it fail authentication? About half the hands. So how many think that the second one is that it fails authentication? No hands, and those that didn't vote, okay, you don't have a say. That's correct. The first one is authentication. Who are you? Can we establish your identity and prove it? The second one is authorization. Once we know who you are, we know that this guy is perfectly well from Faroestan, and that means that we will not let him in. In ASP.NET Core, those two things are separated concerns, and the glue between them is HTTP context of user. So we start with authenticating the request, establishing the identity. That ends up on HTTP context of user. If you're writing a Razor page and a web API controller, anything, you can usually just type user, and the identity of the caller will magically be there. It's thanks to the authentication having run already. Then we have the authorization rules that work based on that established identity. So let's start with authentication. The authentication API in ASP.NET Core has a few methods. These are available as extension methods on HTTP context. You can do HTTP context dot, for example, authenticate async. And I start with the tricky one, because I think the naming of this is, to me, this is a very confusing naming. This actually means, can we get information about the who you are? Do we have anything on the request? A cookie, a bearer token, something that tells us who you are. If we don't have that, we can call challenge async, which is return some kind of response back to the caller that you should get authenticated. And then we have the one that I confused with authenticate async, sign-in async, which is when we have validated the username and password, or in some way done the initial validation of the identity, we call sign-in async to establish a session. Remember me for the duration of the session. And then I think you can guess what sign-out async is about. Forget me, for now, at least. The final one is forbid async, which is, we know who you are. This is authorization, it is denied. We know who you are, but you are not authorized to access this resource. It doesn't make sense to challenge in that case, because challenge was all about please log in or establish your identity. But if authorization failed, wrong button. If authorization failed, then we know who you are. It doesn't matter if you log in again. You will still not have access. So 5 basic APIs that are usable. And I find that people, we are so used to having HTTP contexted user that we kind of forget that these APIs are available, that we can control this ourselves. So let's take an example of one authentication mechanism that is available in ASP.NET Core, the cookie handler that is used to establish a session in a normal server-side application. So what would authenticate async translate to? Well, it translates to validate the cookie. We have an incoming request. Authenticate async checks the incoming request, sees that there is an authentication cookie, decodes it, validates signatures or whatever we have to ensure that it's a real cookie, and then returns the result. The next one is more tricky. Challenge async. I mean, a cookie scheme, what can it do? If this was a Google login handler, Google login means that if we challenge Google, it means redirect to Google to sign in and do the stuff over at Google and then come back. What can a cookie handler do when we challenge it? Well, the only thing it can do is to redirect to login page, and it doesn't even supply the login page. You had to write it yourself. So it redirects to a predefined or configured path, and then you are expected to provide a login page at that URL. On that login page, you are expected to call sign-in async, which will cause the cookie handler to create a cookie and write a cookie about the session. If you want to build a logout button, you call sign out async. And finally, for bid async, it's the same as the challenge. There's really not much the cookie handler can do itself. It can just redirect to an access denied path, and you have to create that path yourself. But the good thing with this API is that it's agnostic of the mechanisms. So while it might feel a bit awkward sometimes to work with if we think of this as working on cookies, the strength is that it works also with, for example, a bureau token in an API. Authenticate async in a bureau token. Well, it checks the incoming request for, but now it doesn't check for a cookie, it checks for a bureau token, validates the token. Challenge async. What is the API way to say we don't know who you are? Do we redirect to a page for an API? No. 3 digits. 401. 401. Challenge async. So if we return challenge, if we call challenge async on the Jort bureau handler, it will cause a 401 to be returned. Sign-in async. Well, something where we use a bureau token where the token needs to be attached to every single call. There isn't even a thing, a notion of a session, so it doesn't make sense. It's a no-op. Sign out async, same, of course. So forbid async, what would that be? If challenge is 401, what is forbid? 403, yes. So we return them. And as you see, the API is the same. It's an abstract API, and it can behave differently depending if it's a machine-to-machine scenario or if it is for a user using a browser. Once we have authenticated, so we have done the first part of this 3-stage pipeline. Once we've authenticated, I said that somehow ends up in HTTP contexted user. And this used to be magic for me. I mean, we just use HTTP contexted user, right? But then I one day got along to actually read the authentication middleware source code. I was curious, how do HTTP contexted user come along? It's not that hard. The authentication middleware calls authenticate async to get the current user, and then it just sets contexted user to the principal it got from the cookie handler. So, surprisingly simple. And this works well if we have a normal web application with username passwords. The cookies will handle everything. But are you really happy if you go to a new web page, web application, and you end up with the prompt, please create a password? So either you use an existing password that you remember, or you have to create a new one and possibly add it to your password manager. It's so much more easy if they actually supply one of these buttons. Then I can just use my Google account to sign in, or sign in with Apple or Facebook, or whatever one I choose, but that lets me not have to create yet another password. And what that means is that we need some kind of authentication handler that can handle the interaction with an upstream provider. Google handler handles the interaction with the upstream provider. And that works perfectly well on the first request. We make a request, we challenge, we get redirected to Google, we get back, you navigate to the next page. Do we navigate to Google again? To check for every page navigation? Do we navigate back to Google to check? No, of course not. We need to establish a session in our application. And, well, I guess they could have made the Google handler know how to do that. But we already have the cookie handler. So let's use the cookie handler and make them a separation of concerns. So the cookie handler knows how to maintain the application session. And then we have remote authentication handlers that know how to interact with an upstream provider. If we have two upstream providers to choose between, we still have one cookie handler. And this brings us to the same API applies for the Google handler. Authenticate async. Well, now it's that one that doesn't carry meaning. You can't query the Google handler who is the currently established user, because that's the business of the cookie handler to establish the session and keep track of the session. Challenge, however, that's something that the Google handler definitely knows how to do. It knows that if you challenge it, it should initiate the redirect to Google, do all the security stuff that needs to be done before redirecting, and then once the response comes back from Google, it should do the post-processing, process the response, validate it, and once done, the Google handler needs to establish a session. It doesn't implement that itself. It doesn't make sense. It calls sign-in async on the cookie handler. Sign-out async, however, has a meaning. If we do single sign-on, we might want single logout. And finally, forbid async. A remote authentication handler doesn't carry meaning. So this is fine. We have a situation where the Google handler or the remote handler and the cookie handler, they take turn and implement some of these each. But what if we start to add even more authentication handlers? So we add cookie first. Under the hood, that will configure options to supply an I options of cookie options. And it will register the cookie handler in the DI system to make the cookie handler available. Then we call add OpenID Connect. For example, we want to interact with Microsoft Entra ID. We have the options and we have the handler. Then we call, but our application does not only offer sign-in with Microsoft, it also offers sign-in with Identity Server, which is the third-party OpenID Connect provider. Then we add a new set of options, but it's the same handler. So these options, and we have now two instances of the OpenID Connect options. So the way we handle these is through the concept of a scheme. So a scheme is a name for a specific handler and a specific configuration for that handler. So when we add cookie, we register the cookie scheme, and that is implemented by a cookie options and the cookie handler. When we call add OpenID Connect the first time, we name the scheme Identity Server. And that is one named options set of OpenID Connect options that are specific for Identity Server. And then when we call it the next time, we name the scheme Entra ID, so we have another copy of the OpenID Connect options for each scheme. And that gives us the possibility to, when we call these methods, the APIs, we can pass in a scheme name to select which one we want to call. So in an application where we have remote authentication, which of these schemes, so do we want to call to do authenticate async? The cookie scheme is responsible for that. When we want to initiate the sign in, which one do we take? OIDC scheme. Sign in, well, it's the cookie scheme that's responsible for establishing the session and signing in. Sign out, which one? Anyone want to guess? Is it the cookie scheme or the OIDC scheme? Sorry? Both. Yeah, that's right. I thought this would be a nice question because any answer would be right. But the answer is both, because we need both to clear out our local session that we have with a cookie, and we might want to do a single logout. And finally, forbid, that's the business of the cookie. Okay, so once we have multiple schemes, we need a way to tell the application which one to use. There is one property on the authentication options called the default scheme, which is unless we specify a scheme name, that is used. But it's also possible to set a default scheme for each of the API actions. And there's a fallback hierarchy, which means that most of them will fall back. So if you haven't defined any default challenge scheme, default authenticate scheme, default forbid scheme, or default sign-in scheme, they will all fall back to using the default scheme. But the default sign-out scheme is different. It falls back to the default sign-in scheme, which falls back to the default scheme. And this is also a source of confusion. So now that we have that, I actually want to go back to the authentication middleware source code because I cheated. I made it a bit more simple than it actually was. So this is the actual code. It calls first the scheme provider to get the default authenticate scheme, and then it uses the default authenticate scheme. It authenticates the default authenticate scheme, and it is that result. So if we have multiple schemes, the default one is the one that ends up on HTTP contacted user. Okay, let's move on. So the idea here, I'm moving through a set of slides, and then I have a demo app where we can play around with this. And it's one of those apps, like how many of you have been in a project where we've started cranking out functionality and then let's add security for the last. We'll add that at the end. I've been there. So that is exactly what I did. I made an app, and then I forgot about security, so we can add in the security part together. So HTTP contacted user, once we have that, we can do authorization. And in ASP.NET Core, we use something called policies. So we just set up a rule, say that, well, to access this, we need to fulfill the managed customer policy. And then in a separate place in the code, we define the policies. The important lines are these. We can say that this policy requires authenticated user. It requires a claim that the department claim has the value sales and the role manager. So this is the simple way. And these are, you need to fulfill all the requirements. So you need to be authenticated and be in the sales department and be a manager to fulfill this. There is also a way in the authorization structure from Microsoft where you can do more things, write your own code. We have a policy. For example, you need to be over 18 to buy alcoholic beverages. Is it the same in Norway? 18 at the pub? Yeah. We can translate that into a requirement, which is a class that just carries 18 as a parameter instead. And then we have a generic handler that could check any min age requirement. this example doesn't really make sense because it's a simple one. So let's take another example. Let's take the case to read medical records. At least under Swedish legislation, reading medical records require that you are logged in with strong authentication with a smart card. So that's the requirement, and we have a handler that checks that. There's also another requirement that you have a relationship to the patient in the meaning that you have an appointment or you're currently doing treatment on the patient. That can be checked by an appointment handler that checks the calendar to see that before we return the medical records of the patient, we check the calendar if there is a recent booking or an upcoming booking with that doctor. But there's one case more that we need to handle, and that's the other way to enter the hospital. That's through arriving by ambulance. Nobody sets up an appointment for arriving at the hospital by ambulance. So we need to make another rule and say that, well, patient relationship, don't question that in case of emergency. And this is a voting system, so if any of the handler votes yes, then the requirement is fulfilled, and if all the requirements are fulfilled, the policy is approved. And this structure is definitely powerful. And if you need your handler to be contain complex logic that you need to test, the handler might reach out to the DI system, read a database, go call an API or whatever. Then this is a great architecture because the handlers are services in the DI where you can test them. They can inject dependencies such as data context or database context, things like that. But it's also quite a heavy thing to set up for more simple scenarios. So I often prefer to use the require assertion requirement, which just let us write code. It's a Boolean expression. Require assertion, and then return true or false. And this actually allows us to fix a bug in the previous. So our stakeholders came back and said that, no, you got it wrong. The idea was not that you had to be a manager at the sales department to manage customers. The idea was that you either had to work in the sales department or be a manager. And we can express that as an assertion, because then we can check either one of them. So that's the basic building blocks: authentication, authorization. I also want to bring up a library that is very often used. If you create a new web application and select individual user accounts in Visual Studio, you will get ASP.NET Identity Bundle in your application. There will be a login page where you can there will be forgot password, registers user, things like that will be available in the template. And the ASP.NET Identity System is actually quite pluggable and extensible, so I want to show you that. First of all is that what we get is actually a set of UI pages. They used to be UI pages that actually generated hundreds of lines of code in like 30 different pages in your application. When you selected this option, so you had an account controller and account area in Razor Pages with a lot of pages and a lot of code. And then they found out that people were upset to have all that code in their application. So they invented Razor Page libraries as a way to handle that, where you can put the actual web pages in a component, a NuGet component. And that's brilliant because now we don't have all that code in our application anymore. And it's also brilliant because we all are stuck with this layout. And everyone wants exactly this layout on their login page, right? So what happens is that you have to go to the scaffolding tool and say that please add the code to my project so we can adapt it. And we're back where we started. But there are pages and they are driving it. The important thing I want to push on here is that it's UI pages where you can actually get the source code that is the entry point to your application. And then the ASP.NET Identity Library supplies a user manager, which is what you use to interact with the system. The user manager works against a store abstraction. most templates end up, and the default template ends up using Microsoft's ASP.NET Identity Entity Framework package, which implements the store abstraction using Entity Framework. But if you have an existing database, or if you're not happy with the database structure that Microsoft supplies, you can plug in your own store to ASP.NET Identity and still benefit from the user manager, that API, and what how they handle users. And maybe more importantly, sign-in manager, which is the one that handles all password hashing, lockout, things like that. So when the sign-in manager actually has validated the user who they are, etc., the sign-in manager wants to sign in and establish a session. Of course, it uses an existing component, the cookie handler. But here's a thing that trips us up often. ASP.NET Identity registers their own names for the cookie schemes. So as soon as you add ASP.NET Identity to your application, your cookie scheme is now named not cookies as the default name is, it's now named identity.application. And you get another one. So that's once again, you get another one called identity.external. You actually get 3 more as well, but these are the 2 important. So what is identity.external? Why do we need 2 cookie schemes? I mean, is it to log in 2 people at the same time? No. It's 1 person at a time. No. This is actually a clever thing of isolation from an upstream providers, the data model of an upstream provider. So our upstream provider will redirect to our OIDC handler, which will validate things. And here the OIDC handler will know the identity as described by Google. But when we are using ASP.NET Identity, we have our own database, don't we? And we don't want the Google identity to end up in our application because we want our own identities. We want a user ID that we can find in our database, not a user ID that was the Google user ID. So what the way this is configured is that the OIDC handler is set up to sign in using identity.external, which is not the default scheme. Then we redirect to a separate page, the external login callback page, which picks up, calls authenticate on identity.external to find the external entity. That one can use the user manager API and look, okay, we got an identity from Google here. Do we have a matching record in our database? Do we maybe want to create a user on the fly in our database? So it is a way to have like a quarantine area for people coming from an external provider where we can do some validation and pre-processing before we are happy and, okay, let's say now we have our own representation of this user in our database. Let's sign in that with identity application and call sign out on the external to get rid of the cookie. Then we redirect to target page, and now identity.application is our default scheme, so that ends up on HTTP contact as user, so our target page in the end can just use HTTP contact as user as normal. But when we set up handlers using ASP.NET Identity, it's important to follow this pattern because to understand that the OpenID Connect handler will actually sign in on identity external. The default sign-in scheme will be set to identity.external because any external provider should call that. I want to show you one more thing about ASP.NET Identity, and that is an important structure of the user database. It is that we have a user, and the user is a separate thing from a login. And a login could be, for example, user number 17 from Facebook. And I have user number 42 at Google. The identifiers need to be used in pairs because user 17 from Google might not be the same person as user 17 from Facebook. So the user identifier from the upstream provider is guaranteed to be unique from that specific provider. But if we want to make it unique in our application, we must always use them in pairs. This is stored in ASP.NET users table and in the ASP.NET user logins table. So, well, these are actually kind of the only tables that are really important in ASP.NET Identity. or actually, these are the tables that are mostly used. I have one final mechanism I want to show you before we go ahead to the demo, and that is data protection, which is very much an internal mechanism. So data protection is an encryption system. How many here have tried to use the AES class or AES library directly, creating your own initialization vector? Remember to create a unique initialization vector, and remember to save it. Did you rotate keys properly? I didn't. So there's a lot of AES is a good encryption standard, but there's a lot of work to do to actually use it right. And data protection is a way to have a simplified API. So if we have something in clear text, we want to get it encrypted, well, we protect it. The API actually is called protect. And that ends up giving us an encrypted and signed piece of data that we can then unprotect to give back the clear text. This is, for example, used for the session cookies. So when we have established the identity of the user, we know all the claims, how to describe them, if they are an admin or not, etc. What ASP.NET does is that it serializes that, runs it through data protection, and puts it as a cookie in the browser. Because now it's encrypted and signed, so the user cannot alter that. We can trust the data when it comes back. So it's a really good API. And they also make a really good educated guess on where to store keys, how to separate keys from different applications, and that cannot be used if someone tries to do a ciphertext swap attack. It's not possible. The problem is that this educated guess, it works well on development machine. It might work on a test in your staging environment where you have one single server deployed. It will most likely fail in production where you have multiple servers or containers. So this is a very common thing, that this nice automatic API blows up on us in production. So in all ASP.NET Core applications, we should configure this manually. Call add data protection, set an application name, because the default is to use the path of the deployment. So if you just move your application to another path, then you lose access to all your encrypted data. Setting a name is a good thing. It's also a good thing to decide where to persist the keys. Maybe not temp, but especially if you have containers. If you have a deployment system where you overwrite the file system every time you make a new deployment, deploy a new version, you want this in a dedicated place that is persisted. And you want to encrypt them at rest with something that you know you will have access to, like a certificate. Azure Key Vault. Azure actually works fairly well out of the box, but it's still a good idea to do this to make an explicit configuration. If you run on AWS, Amazon even supplies packages for data protection for ASP.NET Core, where you can store the keys and protect them with the AWS services. So, that's the presentation. Let's go to some interesting thing. Code. I created a small API, or a small page, where I just about forgot to add anything regarding authentication. So I did actually create a login page, but I don't think it does anything yet. So, well, we can try. Let's see if login is Anders. No authenticated user. So no, there's a lot of things missing here. So what is the? Sorry, I should have this in light mode now, right? Dark mode. We don't want dark mode because then you can't dark. Sorry. I should have thought of this before. Use blue extra contrast is usually good when presenting. That is better. And let's do Someone at the back end, is that enough? Yeah? Okay, so let's go to our program. So here we have services. What was the first thing I should always make an explicit configuration for? Data protection. Always make that explicit. Builder.services.add data protection. Set application name. NDC. Persist keys to file system. And protect keys with. Now I have DP API, which is a data protection API from Windows. So Microsoft has had different evolutions of data protection over time. So the ASP.NET Core data protection API can actually use the Windows layer DP API to protect keys. That is simple because it works kind of out of the box, but it uses my user account to encrypt the keys. So if we ever deploy this to a service running under another user account, it will fail. I'll use a certificate instead. And since I don't like typing thumbprints, I'll just use a helper I had. Okay. Oh, it needs to be directory info. Okay, so that's housekeeping out of the way. Now let's add authentication. Builder.services.add authentication. And let's start with adding cookies. That's enough, I think. Let's try and run this and see if it works. So once more, someone at the back, can you read? Or is it okay? Good. So if I click login, Anders. No. It didn't work. Probably because we configured it, but what about the login page? I designed a login page. That's good. Oh, sorry, login control. I can't control login method. I designed it, but did I? No, here it is. To do, actually log in. We forgot that part. So I've gone as far as that. Well, I have a very secure user model validation. We've gone as far as that we can describe the user as a set of claim, but we need to call sign-in async. So let's do that. Await HTTP contact, HTTP HTTP context, the property.sign-in async, and it expects a principal. Okay. Let's create one. Var principal equals new claims principal. Claims principal, there are a few different flavors, but it expects an identity. Thank you. Okay, so we need a claims identity. Identity equals new claims identity. And here's the tricky thing. We can use claims. Let's try this and see if it works. Because this is really one of those odd things in how the API works. Please log in. Anders. Oh, so it says sign in async when principal.identity is authenticated is false, is not allowed. Oh, there's a guard for that. That's good. But I mean, I created an identity here. Why would it say the identity isn't authenticated? Well, this is one of the quirks with this API. There is a property called authentication type, and there is a flag is authenticated. And we use that often in our code, like if user is authenticated, show stuff or whatever. If not user is authenticated, show the please log in message. How is the is authenticated method implemented? Well, it's implemented by string is null or empty authentication type. That's obvious, isn't it? No. So we always need to supply an authentication type. We should always use also supply name and role types where to be explicit with the claim names. So let's put it like this. Use the 4-param version of this constructor. Let's run it again. Log in. Anders. Anders. Hey, welcome, Anders. Woohoo, it worked. So, well, I added a sample here where we can actually try the different things on this. So, challenge. If I challenge the cookie scheme, what will happen? Anyone dare to help me? I'll click it. It takes me to the login page. I'm going to skip that one for now and use forbid. So forbid takes me to the access denied page. And authenticate. If we call authenticate, we get, here it says authentication succeeded, and we get a list of claims. We also get properties. So an authentication cookie, or actually an authentication ticket in ASP.NET Core, contains both a set of claims, but there's also a property bag where you can keep other things around that we need. For example, bookkeeping of the issuance and expiry time of the session. So let's click sign out. Well, it says we're not authenticated anymore. So let's try authenticate. Now it says no authentication result returned. Good. What about adding some more authentication ways? Because just use known password is boring. So I want to add OpenID Connect as well. And here I'm cheating, opt.configure identity server. So obviously there are a bunch of options on this options object that need to be set to work with the demo instance of the identity server. I don't have time to go into details on that. And the idea here is really just to show what it looks like when I have another scheme. So let's run it. Let's click login. Oh, exception handled while processing the request. Now it says that no authentication scheme was defined. There was no default sign-in scheme found either. So now we've added both cookies and OpenID Connect to our application. We need to start telling the system which one to use when. So we can have opt.default scheme. That's data protection. That's wrong. Wrong opt. Opt.default scheme equals cookie authentication defaults authentication scheme. And why not set the default challenge schemes to OpenID Connect defaults.authentication scheme. So whenever we just call challenge without a specific scheme, we will use OpenID Connect. We click login. And it works. What if I challenge the OpenID Connect scheme? Let's try. It sent us off to identity server, to the upstream provider, where I can log in as Alice. I can't, because I can't type. Now, if I want to check the claims that I received, I'm not using the external callback pattern here. So if I want to check the claims, would it be the cookies or OpenID Connect that I query? Which one is keeping track of the session? Cookies. I heard that. You're right. The cookies. So I authenticate with the cookies, and I get all the claims that I received from my upstream provider. Hey, the properties are extended quite a lot as well. We got an access token. That means we got something that we can use to call an API. So let's do that. Let's call, I have an API that I created where the API calls authenticate on the incoming token and then returns it. And we can see that, well, the access token was validated by the API, and this is the claims, and not very nice presentation that the API found in the received access token. What do you think if I call an endpoint where the API would call challenge? What would be the return of that? Someone mentioned it. It's a number. 401. So if the API makes a challenge, it's a 401 returned. If the API makes a forbid, it's a 403 returned to our application. So that's it with what we have with this. But I have one more thing. No, sorry, I have one more thing on authentication I need to show you. So now I am logged in as Alice Smith. My session on this application is maintained by cookies in this application. The cookie scheme is responsible for maintaining the session. So let's sign out of my application. I'm signed out. Now if I click challenge to re-log in again, I'm just automatically single signed on. What happened? Well, I signed out of my application, but I never signed out of the upstream provider. So once I try to sign in again, I'm single signed on. I just bounce right back. Okay, let's try signing out of the upstream provider instead. Yeah, I'm signed out. Let's go back. But no, I'm still signed in. I need to sign out here. Now if I challenge, I'll get to the login page. So if we have single sign-on with an upstream provider, we typically need single logout. But because without single logout, if we just do a local logout, we will be signed in right back again. So this logout button, the real logout button, actually does both. Okay, sign out. That's authentication. We have about 10 minutes left to do some authorization as well. Sorry, I should run this. I have a secure page, a top secure page on my system here, where I decorated it with an authorization policy called top secret. But I never defined the top secret authorization policy. We can actually check that one in the, it's in the home controller. It's not very advanced, just authorize top secret. But we need to add the top secret policy. Builder.services.add authorization opt. Let's zoom in a step more. Opt and opt.add policy. And now we get a policy builder that we can use to call builder.require. Sorry, we need to name it, of course, first. Top secret. Builder.require role admin. Why not? Let's start with that. That's a classical thing. So now I start it. I try to go to the secure page. I get when I try to go to the secure page, I actually end up on identity server because authorization failed. The authorization middleware called challenge, and the default challenge scheme is OpenID Connect. So I ended up here. I can sign in, and Alice is not an admin. Access to /home/secure is denied. Log out Alice. Go through the normal login page, log in as admin. We can check the claims and see that no, Is it case sensitive? I added a special hack for the name admin. I thought I did that. Oh, username must be admin with an uppercase. Log out. Log in. Admin. Admin. Authenticate. Now we have a role admin, and secure should work. But well, I think just giving admin that using admin to let people in, that is a bit too simple. I want something more complex. Builder dot require assertion. I want to write code here, so I'll do context, and then ctx dot user dot find first value. Let's get the name of the user and check if it starts with a good letter. So this is now between me and Alice. Bob is not allowed. I can run this. If I click the secure page, it says it fails because I should have builder require authenticated user first. I mean, I can't go and check the username unless I'm authenticated. So let's just add a dual requirement: authenticate the user first, so that will block the case where, take care of the case where nobody is logged in. I thought. It's evaluating all of them. False. Let's do that instead. I thought it was a brilliant idea to start with A. Obviously, it was not. Yeah, I end up here. If I sign in as Bob, access denied. If I try again as Alice, works. If I sign in my normal application with Anders, I can go there. So we have a way to express more complex expressions for the authorization rules using require assertion. So I'll jump back to the summary slide just to summarize it. Then we do have time for questions, and we do have time for also we do have time if you want to challenge me and have something else you want me to add. We can try. We have a 5 minutes live coding on request. Why not? But we had our web application. We added cookies to it to do authentication and session management. We hooked it up with an upstream OpenID Connect provider to establish and sign in the user and get access tokens if you want to call APIs. We added an authorization policy that only people with a name starting on A are allowed to access our top secret page. And we called an API and saw that the API can accept and validate an access token using the same mechanism. So even though we started our application here without any security, we could add it and save the day. So, questions or impromptu code challenges? Yeah. Take this one. So here. It's on.
I don't want you to make my code. I was just wondering if instead of just faking the authentication, you were authenticating using another API?
Yeah.
With a refresh token.
If we want to authenticate the user with another API.
Which has a refresh token, say.
A refresh token, yes.
So when you challenge or whatever, when your access token expires,
yep.
You only have the cookie, you don't have the identity server scheme.
Yep.
How do you refresh that token?
Okay, so this is, let's put it like this. This talk also comes as a 2-day workshop. This is the first. This is most. What we've done today is like the morning and part of the afternoon in the first day in that workshop. So I had to leave out quite a few things. But you are right. The access token should be short-lived. I'm lucky here because the default access token lifetime here is 1 hour, and the talk is just 1 hour, so my access token will never expire during the talk. And also I'm logging out and logging back in all the time. The right way to solve it is that when we log in with OpenID Connect, we would request a refresh token so that whenever our access token expires, we can reach out to Identity Server with our refresh token and say, please give us a new access token. And then whenever we call an API, we need to check if the access token we have is within its lifetime currently. Duenda software we supply for .NET, an open source and free library called Duenda Access Token Management, which handles that for you. So let's see the API call here. So there's so much code that I never got around to show. So this is what I do here. I call get token async to get the access token before I call the API. I'm not sharing the right screen. Of course, here it is. So I call get token async to get the access token out of the session. This will just get the access token as it is. If it is expired, we'll still get the expired access token. If you add the Duenda Access Token Management Library, you can call get user access token, and that will keep track of lifetime and refresh for you. So yes, it's definitely a point that at some point in time, our access token is expired, and I tried to get away with it. I didn't. Thank you.
Thank you. Thank you.
Anyone else? Yes, can we hand the microphone up there quickly? Thank you.
Yes. How do you log out of multiple schemes?
How I do log out of multiple schemes? There are two ways to do it. Either you call sign out async multiple times, which is the simple way, but that's also one of the things. Sorry, I need to switch monitors here to be able to point what I'm doing. So let's see that actual relog out button that I implemented, how it works, because it is a bit more complex. I actually check if it is the cookie scheme only that I sign out to. I just call sign out async because that call will just cause a cookie set cookie header to be set, and then I can return a redirect which is executed right away. If I want to sign out to multiple schemes, if I want to sign out, this is the method that I want to check. So in the logout button that did this automatically, I've actually first checked the auth scheme property to see if I had a remote authentication scheme that was used. If it was, I do return sign out, which will sign out of both the cookie scheme and perform the redirect. And I do also send in an authentication properties with the return URL that once we've been up to the other provider and click back, where do I want to go? So there are a few steps on this. This entire sample application is available on my GitHub account in the ready-to-use version. So if you want to dig into the details, the sample project is on my GitHub account, so please feel free. And I think that's it. I think we'll have to wrap it up there. So thank you very much for having me here, and enjoy the conference.